Hi, welcome to lesson 9 in the series of 8051 microcontroller programming and interfacing. For more information, you can visit us at www.jcbrolabs.org. You can also download the required softwares and content of this lecture from that website. In this video, we'll talk about interfacing of IR sensor to 8051 microcontroller, and we will also talk about how this IR sensor works. So let's first start with the working of the IR sensor. So IR sensor finds several applications in remote control and obstacle avoidance and black line following itself. So IR sensor means a sensor which is based on infrared rays technology. So what actually happens in, we have different kind of LEDs, suppose red LED, blue LED, yellow LED. So these LED specific emits light in the visible range so that we are able to see it. Similarly, we can create LEDs which emits light in the range of IR range. So LEDs which emits light in IR range, those LEDs are known as the IR LEDs. And one of the other device which is used in this IR sensor is the photodiode. So if you have gone through some of the basic applications of the diode, so you must have learned this one, photodiodes. So this photodiode is nothing, it is again like a normal diode, but when we connect it in forward bias, it acts as a normal diode. Okay, so when we disconnect it in reverse bias, so generally it doesn't flow any current, but as the light emits on it, it starts conducting. So suppose we have connected +5 supply here and ground here, and right now, and with 1k resistance or less, right now this photodiode is in reverse mode. So if there is no light, it is in dark, then it will act as an open circuit, and at this point we will get 0 output or +5 output. But as lights falls on it, so depending on the intensity of light, it conducts. So if it is conducting heavily, that means its resistance is decreasing. So if resistance is decreasing, the value of the voltage across it will be less. If it is light intensity which is emitting on it is less, then the value at this point will be higher. So this value, or this V naught value, this V naught value becomes the function of light intensity. That means how much light is falling on it. So if light intensity is increasing, this V out will decrease. If light intensity is decreasing, V out will increase. So this is the basic circuit diagram of the photodiode, and it is how it is used. So we can create a IR sensor based on the combination of that, and the circuit diagram for that is very easy. What we do, we create a LED, we connect an LED. Okay, it's LED needs to be in forward bias, so we connect an LED. Okay, again I'm doing the same mistake in reverse bias. So we have connected an LED. This is 5 volt, this is ground, and this is a variable resistance. So if we are applying a variable resistance, we can change the intensity of this IR LED. Okay, so this is the circuit diagram for the transmitter. For the receiving end, we have connected photodiode in a reverse bias mode. So we have connected forward bias. we have connected a photodiode in reverse bias mode, and the symbol for photodiode is with this arrow inwards direction. So this is R1 and this is plus 5 volt. We are taking the output from here, and then so IR LED is there, and they are connected in such a way both have the phase in forward direction. So this particular output goes into an op-amp, and we have connected an op-amp in comparator mode. So in comparator mode, what we mean by it, we this is positive and this is negative, and this is plus 5 and this is ground and this is Vout. So R2 by R3. So the value of the voltage at here, so this V1 will be simply 5 into R3 by R2 plus R3. Okay. So what actually we are doing in this comparator mode, if the voltage present at here is greater than this voltage, output V out will be if supply 1 is supplied to plus 5 and another is supplied to ground, then this V out will be nearly 4.7 or 4.9 volt. If this voltage is less than this V1 voltage, that is the reference voltage, then V out will be 0. So are you getting it? So what actually happening, if this particular reference voltage or the voltage which we are getting at this photodiode point is greater than this reference voltage which we have set, and whose value can be determined by this formula. If this value is greater than this, output voltage will be 4.7 volt, that is nearly plus VCC, because it is a positive comparator. If the value here is less than this reference voltage, that is V1, less than reference voltage, then V out will be 0. So effectively at the output we will get 1 or 0 depending on the voltage available here, and this available voltage will determine by how much light is we are getting reflected, or how much light is being emitting by this IR LED. So this is the basic circuit diagram. Now if we want to create an IR sensor, everything depends on the how we are arranging them. So in the IR sensor there is a PCB, and whatever circuit we discussed, that is connected here, the circuit we just discussed in previous art. So if we connect IR sensor, so this is actually a digital IR sensor. So actually it is converting giving output in the form of 1 and 0. So we can make it like digital IR sensor. So here we have an IR LED, and then here we have a photodiode. So by this we have created an IR sensor or obstacle detecting sensor. So IR LED is emitting lights in forward direction. So if and this photodiode is not receiving anything, so the output here output will be 0. As soon as there is some obstacle is there, some of the lights will come back to this IR sensor, and we have set the reference point within the circuit as discussed previous one, and the output will become 1. So are you getting how the IR sensor is working? I am repeating again, in IR sensor there is a PCB circuit, and there is a PCB circuit, and IR LED is emitting light. So if there is no obstacle, all the there will be no coming back IR radiation. There will be no IR radiation which is coming back to the photodiode. As soon as there is an obstacle, this radiation will come back to the photodiode, and then photodiode will become 1. So again, we discussed there are two variation in the resistances and the reference voltage. So based on that reference voltage and the intensity of the LED, we can also change this much of distance of the IR sensor. That means after how much distance it will detect. So this is the basic circuit diagram of IR sensor. Now if you may have some doubt, you can also comment on the link provided below. We will see a real IR sensor and then how it works. So this is the IR sensor, and here we have three inputs: VCC, ground and out, in order to provide the supply. This is the op-amp, this is variable resistance, and here we have IR LED and the photodiode connected in the place. From here we can get the output. So these particular sensors which give output in 1 and 0, those are known as the digital sensors. So here by using this op-amp we have converted into a digital sensor, so that when obstacle is there it will give 1, and when obstacle is not there it will give 0. So we have connected here same IR sensor. We have provided the supply and all the things there, and then we can change the distance at which it can detect any particular object by varying this resistance. So right now if we see this is our object, let's say, so it is detecting an object at a range of nearly 4 centimeter. Okay, so when our object is even at 4 centimeter, it is also detecting the object. But if we want to reduce the range, and okay, now let's change the resistance value. Just by changing this variable resistance value we can reduce the range of the object. Now it will not detect at 4 centimeter, and let's see up to where. Okay, now it's detecting it. Now its range is nearly 1 centimeter only. So when object is at 1 centimeter distance, only then it is detecting it. So this is how we can change even the distance or the detecting range of the IR sensor. Now if the range is different, let's try with the with this phone which has this black color, and let's see whether it is able to detect it or not. Okay, oh no, it's not detecting it. So this IR sensor is not detecting this black surface because all the IR light which is being emitted from the LED, that has been absorbed by the black surface and it has not been detected. So in sense, when this range is small, we can convert normal obstacle detector IR sensor into an color detector IR sensor. So it can't detect black surface, but it can detect white surface as well. So we can use this particular operation or this particular property of this IR sensor while making a white line or black line following robot. Now in normal mode we can use this particular sensor as obstacle avoidance robot. So let's try to increase the range further, and let's see if there. Okay, its range is permanently increased. So now its range is increased to this much of distance, so it is able to detect up to 6 centimeter. So right now this particular sensor, so it is not coming into the video frame, but right now it is detecting, and our obstacle is at nearly 6 centimeter away. So when the range is high, at that time it can even detect the black surfaces, but the range for black surfaces will be less. For right now, for black surface its range is 2 centimeter, while for the white surface its range is nearly 6 centimeter. So depending on the value of the resistance we are providing, we can change the distance, we can change its behavior with respect to the color as well. So this was a brief intro of this IR sensor and its working. Now let's come to the programming part, when we will interface the output of this IR sensor to the microcontroller and see how this microcontroller behaves differently. Now let's write a program in embedded C language for detecting the same. So this is till now we have made all the starting portion of the project. We have created a new project and all the things which we have discussed earlier videos. So we are doing it directly. So we also have added the files here. So let's write hash include reg52.h, and then okay, we need to create a delay as well, void ms delay, and unsigned int, and then void main void. Let's first write the program void ms delay and unsigned int a. So if you have any doubt related to this delay program, refer to our previous lesson. In that lesson we have discussed how to write this delay subroutine and all the things which we have discussed there. So unsigned int I comma j, and then for I equals to 0. Okay, let's make it t. I equals to 0 till I is less than t, I plus plus, and keep on making this program for running. J equals to 0 to j is less than 1275, and then j plus plus, and it will keep on moving here. So this is the delay subroutine. Now we have learned as soon as there is an obstacle it gives 1, and when there is no obstacle it gives 0. So what we have done, we have connected our circuit or the sensor with the pin 1.0 of the microcontroller. Here we have connected IR sensor output. IR sensor output has been connected to P1.0, and for the demonstration purpose we have connected LEDs to the port 2. That means 8 LEDs are connected there, P2.0 to 2.7. So what we will do, when there is an obstacle, here we will get 1, and at that time all these LEDs should blink alternate. That means alternate blinking. And when there is 0, when there is no obstacle, half of the LED should blink and half of the LED should not blink. So in other sense, if we make a truth table of it, so it is sensor, and here LED pattern, how this LED will glow. So we have discussed in previous lessons what pattern should goes for making alternate and for half. So you can visit our previous videos as well. So when sensor output is 1, LED should goes with 0x55, and after some delay there should be 0xAA. And if sensor output is 0, so first should be go 0x0f, and after some time 0xf0. So in this, half of the LEDs will blink, will turn on, half will remain off, and after that half will which will on first, they will turn on. In this, when there is obstacle, all the LEDs will start blinking alternatively. So now let's write a code for that. First of all, as we have discussed, we need to create unsigned int a. In this variable a will read the content of the port 1, because the sensor output is connected to the port 1. So now while create a infinite loop, and because we want to make it work continuously. Now let's first the status of the pin. So we will read the status of the port with the masking, so that only pin 1.0 is accessed. So P1 it gets AND with 0x01. So if there is an LED sensor, there is a obstacle in front of the sensor, A content will be 1. So if A is equals to 0x01, port 2 output should be P2 is equals to 0x55, and then we should call delay 100, and then P2 equals to 0xAA, and then ms delay 100, and after that it will again check the status of the pin. So here we are checking the status of the pin, checking the status of the sensor. Now we will make else because there are only two states, so no need to worry about writing other if else statement. When we'll be doing some other program like motor interfacing and creating obstacle avoidance robot, then we will write more if else statement. So ms delay, as we have discussed, it will when there is no obstacle, so 0x, it should simply make half LEDs on at a time. Okay, so this is making this one, and this portion is making implementing this particular logic. So let's check it. It's nearly completed. Okay, done. Let's start debugging. And okay, let's make a ports because we have the two ports. So connected port 1 is 1. So let's say we step 1 by 1, we go into 1, and LED will turn alternatively. And let's make it 0. So it should go into half of the LED. So half of the LED will go into, and it will make it continuously. So it's working fine on this debugging section. Let's stop it debugging, and now let's burn the same hex file into the microcontroller. So our previous procedure, must connect, and then identify, okay, open hex. So we are in lesson 9, and then upload. So it has started writing the program. So let's wait for some time. It's nearly done. Now we have connected the output of this IR sensor to the pin 1.0 of the microcontroller. So as we have discussed in our programming part, when there is no obstacle in front of this IR sensor, half of the LEDs will turn on and half of the LEDs will remain off, as right now there is a pattern. And as soon as there is an obstacle like this one, LEDs will start blinking alternatively. So this is how our program is working. So when there's an obstacle, LEDs are blinking alternatively, and when there's no obstacle, LEDs are half of the LEDs are blinking and half of the LEDs are not blinking. So this is how we can apply different logic based on the output sensor, and we can force or we can program the microcontroller to work differently. So this is how we can interface the IR sensor to the microcontroller, and we can force the microcontroller to work differently based on different states, whether there is obstacle or not. So we'll learn in our next video how to interface DC motor to the microcontroller, and next video we'll learn how to make obstacle avoidance. So that's it for this video. Thank you.